Eighth grade lesson 6.1 is identifying and representing functions, and that sounds all fancy, but it's still building on the same understanding of things that you have built up and you're pretty good at by now. So let's look at the first example the book gives us about what these functions are, kind of exploring and discovering what represents a function. So we are given this scenario where Carlos needs to buy some new pencils from the school supply store at his school. Carlos asks his classmates if they know how much pencils cost. Angela says she bought 2 pencils for 50 cents. Paige bought 3 pencils for 75 cents, and Spencer bought 4 pencils for $1. Carlos thinks about the rule for the price. The rule is kind of a key word here for the price of a pencil as a machine. When he put the number of pencils he wants to buy into the machine applies a rule and tells him the total cost of the number of pencils. And the reason I said rule is because that's kind of what we're talking about with functions. They're kind of the rules, or what the formula is, or what the factory is doing. So here they don't really have a question they're asking us, but you could see they have empty spots here, so we're going to be wanting to fill that out. So that's what I would underline if I were to underline anything. Circling information, I have 2 pencils for 50 cents, 3 pencils for 75 cents, 4 pencils for $1. If you needed to draw it, sometimes it's helpful to draw. 2 pencils were 2 quarters, 50 cents. 3 pencils were 75 cents. And 4 pencils were $1. And so just drawing the picture, you probably are starting to recognize the rule of what each pencil costs. Because here I had 2 quarters, I had 3 quarters, I had 4 quarters. So each one is probably, or is 1 quarter, 25 cents. So our rule, and you guys have gotten to the point now where you're recognizing what rule is in play. We can say whatever X is, my input is run it through the rule, and I'm going to get spit out Y, whatever my output is. And what we recognize is 1 pencil would be 25 cents. And you guys are at a stage where you would say, oh, 25 cents times whatever X is equals Y, or Y equals 0.25X. So you probably recognize that right away because you've been practicing it so very, very much. So 2 pencils, we run through the rule. 0.25 times 2 gave me 0.50, 50 cents. 3 times 0.25 gave me 75 cents. 4 times 0.25 gave me $1. So here they're just asking you what's the rule, and so here you're just going to put 0.25x. And so what if you have 12 pencils? Okay, well you're doing 0.25 times 12, which is $3. And so that's what they're getting to understand. Use the prices in the problem to fill in the total costs in row I through so 1 through 6. Is that a 6? 1 through 5. Describe any patterns you see. Use a pattern to determine the cost of a 1 pencil. A 1 pencil is 0.25 cents, which, I don't know, our brains went to it right away, or at least mine did, and I think because we've been working on this so much over the last several lessons, probably that's what your brain did too. The draw it helped too. Okay, so something to keep in mind about a function is that a function assigns exactly 1 output for each input. An input can't have more than 1 output, because what we're saying is, for this function to apply, we're taking an input and we're applying a rule to it, and with that rule applied to it, we're going to get an output. I can't take that very same input, apply the very same rule to it, and get a second output that is different from it, because I'm doing the same input and the same rule. So if every input in a function is going to have 1 and only 1 output, because you're applying the same rule to that input, you can't get 2 separate outputs. So if I were to look at these inputs and outputs, 1, we don't know what rule was applied to it, but whatever rule was applied to it, it gave an output of 2. 1 does not have any other output out here, so that's good. If it did, we don't have a function. In this case, 1, the input, has only one output. 3 has only one output, 8. 7 has only one output, 6. So because each input has only one output, it is a function. When you look over here at input and output, we have 0, it has just one output. Then we have 2, and it's saying it has an output of 4, but also has an output of 5. This is not a function because if I take the input of 2 and apply a rule to it, I am not going to get 2 separate answers. I'm not going to get 2 separate outputs. So when you see an input that has 2 separate outputs or more, then what you know is that that's not a function. Okay, so we have function, yes, check mark, and not a function because of the 2 outputs. Now, if we were to look at this as a graph, I think that the lesson gets into this in another example coming up, but if you look at this as a graph, each of these, 1 has an output of 2, 3 has an output of 6, 7 has an output of 8, and it may or may not be linear. That's not really what we're looking for, but we're making sure that every input x has its own output. If I were to look at this one, at 2, I would have y at 4 and y at 5, and they're vertical to each other. They're vertical to each other. And so if you see this happen on a graph where one input has 2 separate outputs, then you know that's not a function. So yes, a function, not a function. Okay, so let's look at this one because it's asking us, is this a function or is it not? And if it's a function, each input will have one output. So I have 7, this input has one output. 8 has one output. 9 has one output. And 10 has one output. But something I notice here is this happening. Can 2 different inputs have a same rule applied to it and end up with the same output? Something to think about if you want to pause and think about it. Go ahead and pause and think about it. There is a way, something I can calculate 8 times, and a calculation I can do with 8 and a calculation I can do with 9 that would give me an output of 1, the same calculation to both. If you want to pause and ponder it, go ahead. Here we go. I'll show you one though, one that I can think of. Let me do it this way instead. If my equation, linear I'll even go, is 0 times x plus 1, and my input is 8, or my input is 9, this is going to be 0 plus 1, so my output will equal 1, and this is going to be 0 plus 1, so my output will equal 1. So is it possible that different inputs can end up with the same output? Sure, and here's an example of how. There's probably a lot of examples. That's what comes to my head. I did 0 times 8 plus 1, 0 times 9 plus 1. Same rule, different input. So can different inputs share an output? Yes, it's possible, but one input can't have more than one output because we're running a same rule through it. So that's just something to keep in mind. So in this case, this would be a function because each input has only one output. That has only one output, and that has only one output. It's not saying that the input 9 has 1 and 2 as a possible answer. 9 only has the one output, and that's it. Is this one a function? Well, let's see. Is there a rule that I can calculate 3 with, that same rule being calculated with 3, that's going to give me an output of 0, and then also an output of 2, and then also an output of 4, and then also an output of 6? A whole rule that I could do that with. And there's not. There isn't one that I can say, okay, the calculation is this. Plug 3 in, what'd you get? Oh, I got 0. Okay, do the same exact rule again, plug 3 in again, what'd you get? Oh, I got 2. No, it doesn't happen, right? If it's the same exact rule, the same exact calculation, and you're plugging in 3 every single time, you are going to end up with one output, the same output over and over and over again. So this would not be a function. Not a function! So how can I determine whether something is a function from a table? Well, here are all my inputs, and here are all my outputs. And I just need to keep in mind a couple of things. And actually, I really just need to keep in mind one thing. An input cannot have more than one output. So I'm going to look through my inputs here. There's an input of 5. He ended up with an output of 7. Here's an input of 10, different from that one that got an output of 6. This is an input of 15, got an output of 15. This is an input of 20, got an output of 2. An input of 25, got an output of 15. They're not even asking me to find out what the rule was that was going on there. They're just asking me, is it a function or is it not? Each input is different from one another. They all have a different output. I'm a function. Let's look at an example from another table. So this time I have an input of 1, 5, 4, 1, and 7, and an output here. Here's something to keep in mind. Look at this input of 1 and an input of 1 again. Input of 1, input of 1 again. All right, I'm still okay as long as whatever the output is for 1 is the same on both. And oh no, 1 can't have a different output if it's being run through the same exact rule. So because there's a 1 here with an output of 10 and a 1 again with an output of 4, this is not a function because an input cannot have more than one output, and this 1 has a 10 output, and then 1 again has a 4 output. So that's all you have to do to determine if from a table information is a function or not. Is check your inputs. If there's repeated ones, then check and see if they have the same output. If this one had said 10 and not whatever it said before, I forgot, but if it said 10, then I was in good shape still because that input still had the same output, but that is not what it had there. It had 4. 4 is what was there. 4 is the output it had. It can't have a different output than it did before because we're running it through the same rule, the same calculation. And finally, the third part of this lesson regarding functions. So the first part was what in the world is a function? And so now we know the input can only have one output to be a function. So that's what we're keeping an eye out for. The second part of this was how can I tell from a table? So we just looked at that. And the third part of this is how can I tell if it's a function or not from a graph? So I'm going to show you that right now. So I have this graph here and all of its points. 1 on the x turn goes 70 on the y, 2 on the x turn goes 70 on the y. So what I'll find is I have a 2 here as my input, 2, and I have a 70 output and an 85 output, a 70 output and an 85 output. This is the same input. And if it was a function, I'm saying that I'm running it through the same calculation. And if I plug 2 into an exact same calculation, I'm going to end up with the same output, right? Well, this is saying if my input is 2, I got 2 different outputs. That's not a function. So anytime you see on a graph where the input of x has 2 different possibilities, that's not a function. So this here and this here keeps it from being able to be called a function. Now, this doesn't mean that graphs can't end up this way. Sometimes when we're plotting information in graphs for whatever we're plotting it for, there's a variety of reasons. It doesn't mean they can't be that way. It just means that this graph is representing information that's not representative of a function, of a specific rule that's happening. So if you see the vertical lines happening where this input gave me 2 or more outputs, then I would just say not a function. I could have also just noticed here by my inputs are my x coordinates. that's a 2 and that's a 2, and they ended up with two different outputs with two different y's, oh, well then that's not a function. 9 is the same input and I got two different outputs. Okay, so not a function. Doesn't mean that this is not valid information or whatever they graphed is wrong. It just means there isn't a function, a rule being applied to these numbers continuously for each of these situations. So that's this lesson it's all about, is it a function and is it not? Is it a function, is it not? And if you keep in mind an input can have only one output, then look at your inputs, look at your outputs, look at your inputs, look at your outputs, look on the table at your x side, your inputs. Do they have only one output, only one answer that comes out of it? Then your output, then you're a function. If one input has multiple outputs, then something's wrong. Remember though also you can have two separate inputs having the same output, because sometimes you can apply a rule to it, like multiply by 0, and end up with the same output answer even though the two inputs are different. So just keep that in mind, but each input can have only one output. So that's the biggest rule you've got to keep in mind on this. Take yourself through it, try it, see how it goes. Let me know if you need help.